So this is Chris Maxwell. He's going to be talking about living systems or build factory. And after Chris's talk, we're going to have 15 minutes to just grab a coffee. It's a little bit tight, so I know it's hard to get like everyone back in the theatre. So yeah, grab a coffee, but be mindful that we've got to get back in here pretty quick.
Cool, this works.
And thanks to the people upstairs that have made the long pilgrimage all the way along the corridors and stairs. So yeah, thanks very much. After Chris.
Good morning. I'm Chris Maxwell. I happen to be the cloud guy at Ubiquity Networks. If it had been 2 months ago, I could have given you some great talks on somewhere else I used to work and what we did with DevOps, but I'm just going to talk about basically a storytelling of the ops side of things as well as the dev side of things. I'm an old school C dev who ended up in operations sort of by accident when things kept breaking and I kept having to fix them. And sometimes in startups and small little companies, you end up having to just do it because someone has to do it. And so that's where I started out, is somebody had to do it, so why not me? Basically, I'm going to talk to you about two different types of systems. Well, first off, I'm talking about the people who build systems. I'm talking systems in general. I'm talking servers. I'm talking things that you deploy to production. I want to talk about all of the things that we design and we take, and the ops guys will eventually take your design and turn it into an implementation, and that's when all the weirdness comes out as you realize deploying to 9 regions in Amazon is not quite as easy as you thought because not everything can talk to each other anymore. We also operate your systems forever, but not forever. We hope they die off eventually, but sometimes we keep them running forever. If you're not an ops guy, this talk's for you too, because a lot of this comes in the dev cycle, and getting you a stable system as a developer as fast as possible, like Michael was talking about, with basically giving you access to the tools, access to the same environment you have in production. We want to give that to you as early in the development cycle as we can, because then you'll see the problems that come out in live production as early as possible. So I'm the guy who keeps the system from failing. Sometimes you're holding the system up. We're doing a lot of things wrong, though. This obviously not helping very much. So what is a living system? A living system is something that starts out of when the business has a need. And I'm talking about the servers and the systems that we run that are around forever, the ones that people have root access to. They go in, they change, they make things happen. And so you start out and you basically, the business defines a need, you throw a server up, somebody goes install some packages, someone installs some code, and the next thing you know, you've got a live system that no one knows how to recreate, and no one knows how to replicate. And so you start cloning it. And then you clone 5 of them, and you hope that you fix all of the things that need to be done. In the Windows world, we used to use something called sysprep, which if you've ever used is a horrible, horrible piece of code that eventually gets there. Sometimes the instructions are unclear, though. Sometimes you don't know where the instructions are, whether the wiki is accurate, whether the code is actually there, whether it's in the right spot, whether you've got the right version, whether you've got the right version of the packages. We don't always follow the instructions either. Sometimes you just end up with things happening in places they're not supposed to. So you get storage in places that you're not allowed to store things. You get people putting log files into places and not rotating them. And 6 months later, after you've thought the system's running great, suddenly it runs out of disk and it fills up its database and bad things happen to your day. Production loads change unexpectedly. And we've all seen this as things scale up in ways that we don't expect. You get a new group of users, a new group of gamers, you get new people involved in your system, and you add a little extra capacity, and then you have to cool it. And so you throw a little chiller in, and you try to keep it cool enough to keep running. Sometimes you've got the wrong tools, and you don't have the right tool, and so you just make the best of what you've got. And that was actually found overhead in a ship that I was working on at the time. The electricians had gotten in to extend a Cat5 run, and that was the way that they had always done it for their automation and control. We put patches into production. We put a lot of patches in that we don't expect. Sometimes patches become the production. That was wired into a drain. So that was fine. The drip was taken care of. The issue was solved. The problem was it wasn't spec'd out for the next build of that same ship. And so the next build had the same problem, and it had the same bucket, and it had the same tube, and everyone did the same thing. That's why cloning is sometimes not the best way to do things. So production is completely unexpected. Just because. You don't have the right parts. You don't have the right pieces at the time you need them. Somebody just logs in and skips your entire CI build infrastructure and turns off Puppet. That's something that happens on a regular basis. Sometimes you don't have any ventilation in wherever you're working on. Sometimes you just need to get the job done. This was an island where there was no ventilation tubing at the time. And so I got my duct tape out and some tape, and we managed to build a small penguin chiller out in the hallway that was about 150 degrees Fahrenheit, about 55 degrees Celsius out in the hallway, but it was cool enough to keep the servers running in the data center. We have inconsistent origins for the systems that we build. So we have a bunch of things that happen too. We've got two different tracks of servers. We've got the one that we started on, then we've got the cloned versions, then we've got the ones that we remember to put the extra changes in for logging, but then we've got the one we cloned afterwards that we forgot to put that change back into. And now we've got a system where we don't know exactly which one is the one we want to clone, we don't know where it is, we don't know exactly what your system's doing at the time. So what do we have as a living system? It's something that's going to live long. It's something that's going to mutate over time. Each system is going to be slightly different. So everyone's going to have a little bit of personality depending on when you built it from. Did you build it from version 2 or version 3 of the long-term release? Where did you start your packages from? What day did you build your packages on? Those are all things that happen in production. And so you might get slightly different package versions. And then the system becomes the state. And so your actual system becomes your tracking state of what your production infrastructure is. And that's a problem because it means you can't replicate it very well. And it means that you're afraid to take it out of rotation, you're afraid to do anything to it because you don't know whether you can get it back into that state. So is this a sales pitch for something? Well, it's kind of a sales pitch for we need to get towards the idea of continuously testing out our states. One of the things is, can you rebuild it? These living systems that we have, these servers that are stuffed in corners, the odd system that's in the data center to keep things running, we want to know whether we can rebuild it fast. When EC2 suffers an outage and all of a sudden everything that you had in one availability zone disappears, can you rebuild it in another? Can you do it the same way you did, or is it going to take a lot of manual work? Do you need to wake up the developer who built the system and installed the packages at 4 in the morning to reinstall them on the same way and the same path that he did in the first time? Do you keep high availability failover? And have you tested it? What's one of the things that we find most is a lot of the testing of high availability systems turns into you've just broken production. The other thing is, do you have a standby host? Has that standby host been tested? Did you put all the same patches onto it? When you rotate that extra load balancer in, do you know that it's going to take the load? Did it get all the system tuning that the other ones did? Does it have the same config? Does it have all the same sites configured? These are all things that happen as you evolve a system where you don't test your build system all of the time. Yeah, what happens when both of them fail and everything's down? Can you rebuild it from nothing? So what's a build factory? Build factory is something that basically it comes back to process engineering. It comes back to a lot of the things that used to happen on assembly line building and the way people used to do production lines for actual physical products. And it's for the business guys, it's running the line. It's making sure that the end result product is the same every time, and we want to run it over and over again. We want to make sure that it works. We want to make sure, basically continuous integration for your code, but also for your production environment. We want to make sure that every server that you get in production is going to be the same as what you specified when you were testing on it. For the dev guys who are here, what we want to do is we want to do this to production on a regular basis as fast as we can. Rather than troubleshooting it, I would rather destroy it and bring it back. Again, I'm the ops guy, so for us, it's kill it with fire. We're going to take your production hosts, we're going to rotate them out and put something new in. And that's the way that the team I'm on right now at Ubiquity is starting to move down towards. It's something where I've come in recently and started on it, and we're already seeing the value in it. We nuked an Elasticsearch cluster yesterday, brought it up about 10 minutes later, and new VPC, new systems, new everything, self-discovered in a way it was off to the races. And that's what we want because we have to go global in a very short timeline. So I'm going to look back on how Build Factory came about and why I'm talking about it and some of the early attempts that people, both myself and others, have made trying to get to this point of where we are. So first off, we started with copying systems. And if any of you are old enough to remember this, you remember that lovely yellow cable. You take one system, you plug it in through the parallel port, you scream and curse at it for a little bit, and you try and get all your files across, and then you customize it. So it was an early version of system cloning, back before we had Ghost, back before we had everything else. Then we had cloning systems come along. We had systems that would come and they would start copying your system from one to the other and making the exact copy. And they'd go for a while, and they'd run for a little bit, and your network wasn't usually that fast, and USB wasn't necessarily available at the time, so you'd plug in a second hard drive and you'd hope it would finish, and you'd sit around a little longer, and then you would start actually personalizing the system. Because you had to go through manually at the end, and you had to install everything. And I had another slide in that order, so I've missed something. This is actually a production note from a system I used to work on. And to restore a system in production, it was 7 pages of screenshots and other things passed on to the guys in the field in order to restore the security system when it failed. And this was a regular thing that happened about once every 4 or 5 months because the code just didn't stay up. And so we would wipe the VM and start over, reload the information, and carry on. Not what you want with the security system. So it was a manual process. That's what I was looking for. After you've done copying everything, you still had to join it to domains, you still had to do work on it, you still had to touch it manually. It still became a system that you couldn't necessarily duplicate without a bunch of manual instructions. So the first way we started with it was we started with scripting. And we started scripting everything because ops guys, we love scripts. This was a long, long time ago. I'm a little embarrassed by some of these samples, but I found this from about 11 years ago where it was a build package and a build system for a firewall. And so you just had numbered scripts and you ran through them one in order, one after the other, and it built the entire system, and then it shipped a product, and you did your final config when you turned it on. It was okay. It sort of worked. It wasn't anywhere near the easy that it is in Puppet. It was actually in source control, so we did get ahead with that. But we didn't actually get very far in terms of making it declarative, deciding what we wanted it to do. If the script ran in a different order, it would often break. These are things that were just not working. So we thought about, hey, why don't we use makefiles? Because they have a dependency graph, so we can depend on everything happening in order. Sort of how you depend on this, you build a graph chain, and suddenly you get to the end, and if the 5 requirements aren't done, then you start over and you go from there. It builds your kernel, it builds your OS, so it might actually build a production system for you. The problem is you have to script everything underneath it. So you get the dependency graph for free, but you don't actually get any of the work of going out and reaching to a remote system. You don't get the package pull in. Everything you have to do manually has a bunch of steps. So today's tools. And I apologize if I'm talking too fast. Whenever I get up here, I talk very, very fast. So I hope you all understand. There's a lot of tools that we have today. I don't want to get deep into any one of them because it's not about the tools. What it's about here is it's about finding something that works within your organization. If your organization doesn't have the team that can understand how to do Puppet, how to do Chef, then use scripting. Okay? Do something that's source controlled and repeatable. The point is we need to get to repeatable systems that we can hit go and have it do the entire process, start to finish, and then finish off, give you the same thing every time, and give you a stable environment that you can deploy anywhere in the world, to any data center, to any production environment, to any customer at any time. These are just a few that I picked up. I know Ansible guys are here, so I'll give a shout out to them because it's an amazing tool. Puppet's great for doing config management as well, for doing runs to build factories, or whether it's maintaining a living system and just keeping your hands off of it by choice. The way we get to it, and the way that's probably the take-home I want to share today, is we want to describe the system. We want to describe what the end result is going to be. Basically taking the process that you have for building it now, which is whether it's in a wiki, whether it's in somebody's doc on their laptop, whether it's on paper in their notes, we take that, we describe, we write down all of the steps. Because those steps are important. When we come back to try and figure out what happened later, when we need to clone it, when we need to repair it in the middle of an emergency, we need to know all the steps. So we start by describing it. Then we start automating, because now we've got a description that can be automated. Now we've got a way to take something and actually make it happen over and over again. And one of the things that people learned a long time ago is automation and checklists and having a list of things to do is actually very, very helpful. One of the early Boeing crashes in the 1930s happened because the system was, they called it, too complex for any one man's memory. And so you think about your ops guys and your devs, do they remember every single step that goes into building your production environment? Do they remember it offhand? And do they remember it at 2:30 in the morning after they've had a few drinks, the pager goes off, and they realize that they have to get into the system, fix it, do the exact steps over and over, and do it with 100% accuracy because they're in a time crunch and they don't have time to do it? And so that's one of the things where checklists help and where automation helps, is because if you have a one-button deploy to say, give me a new SQL server, give me a new Elasticsearch cluster, give me a new web host, if it's one button and you know you just used it the day before, you're not afraid to use it. And that's one of the things, too, is don't be afraid to test your system. You should be able to roll out any host in production, replace it with something else, turn it on, and be confident that it's going to work all of the time. The other thing we can do is we can build large clusters by just replicating the automation. So as we get better at doing the automation, we start figuring out how to make it repeatable in different environments. So if I can do this in 3 different availability zones right next to each other, and I can make them all talk and realize what their local AZ is, what systems are nearby, then I can tie them together with a bridge at the top, and I can put them together through either communication and replication. We can do things in order to link them together, but we can do it where everything is the same, and we just go. Then we want to repeat. We want to try and make absolutely everything repeatable. We want to make any given system not actually important. So we take the individuality out of the systems that we have. A band like this has maybe 100 members. Each one of them has a position to play, but a lot of them that come up in from like 3rd trombone, 2nd trombone, and 1st trombone, they come up, they know the parts, they move on. So you bring your juniors in, and they understand some of the system, and then they cut to be replaceable. And so you get a bunch of units that are working together that have all been through the same training process, get to the same base readiness, and then suddenly they're able to go forward and move as a team and work together. So that's a build factory. It's something that we have a short life on. We replace it for every change that we go. So when your CI runs, there's no reason you can't rotate out your production. Each system should be the same and better be the same. You hope it's the same at the end of it. And the actual procedure becomes the state, because your procedure and your declared way of automating it becomes the actual state of the end result. You track the entire system, and so the end result doesn't matter anymore. And then when something jams deep in the system, it becomes a whole lot easier to deal with. Sometimes we get scraps of paper thrown in things. Sometimes you get a bad memory DRAM slot, sorry. Excuse me a quick sec. Sometimes you get a bad rack, sometimes you get a bad server. The thing is now we can replace it. Now we don't have to worry about recovering that one system. We don't have to track down an issue with the storage network. We don't have to track down an issue with the network. We don't have to bother troubleshooting all of those things. And this is one of the first times in history where we can deploy a system in 60 seconds. I know that people have come up with ways to do it in the past. I know some hosting providers allowed you to do that. But this is the first time where in EC2, in Rackspace, in any of the public clouds that are out there, you can have a new host in 60 seconds. And you can run your full build deployment, if you haven't imaged it already, in another 10 or 20 minutes. And so now, production patches start to take over. You look at it, you say, this is a mess. Why would I want to work on this and try and debug what's happened to this? I'm just going to rebuild it, because I'm going to hit the one button, and it comes out looking pretty. And that's where you get a chance to start over again with every given build. And so your procedure to get to that end result becomes a little convoluted over time as people add features, as people do things. But because you've got it written down, you can take out the things that don't matter anymore. So in the cloud, a live replace of 1,000 systems might take 1 hour of minimum billing. So you've got 1 hour out of your entire month's billing. That's what it might cost you to do a full-on rolling production deploy of everything. In your data center, okay, this is tongue-in-cheek because we all have spare capacity, right? In reality, we don't actually have that much capacity, but if you do a rolling replace on it, if you're using virtualized systems, or if you've got something like Cobbler set up where you've got automatic deployment, you can roll through your rack and actually do a live replacement of systems while it's running. So my takeaways for today is I'd really love it if you guys can start describing it, automating it, producing it, and repeating it. Because that's the way that we make everybody happy. Your ops guys will be happy because they know that they can wake up at 2 in the morning, everything's happy, hit the button, it's back to normal. If I need to rebuild it on the West Coast, I can go in and run a bunch of scripts or a bunch of build processes or hit the Jenkins deploy button, and suddenly I get a cluster up in the West, I can redirect my load balancer, and we have a very good day happening. And I go back to sleep 15 minutes later. And that's where we want to get to, is the point that the actual production systems don't matter, it's only the data matters, and we'll deal with the data as part of our regular process. So does anybody have questions? Because the answers are somewhere out there. This isn't about any answers, so I will take questions and I'll answer anything I can, but I don't have all the answers. I don't have the right tools. I just have a way that has started to come together and started to be something that's repeatable and seems to work in the environments I'm in.
I have a mic too.
Oh, cool. I'll also take heckles from the back row.
Yeah. can't get the mic at the top, but if someone wants to shout.
We got a mic up here.
Up here, we got.
Well, I can just yell. Do you have a way of taking snapshots out of production? Because sometimes we have an issue where production hangs, and you press the big button, and it's back to normal, and an hour later it's jammed again. And what we would really love to have is some way of snapshotting that to a developer workstation, and then burn it with fire.
Okay, I'll just repeat the question. The question was, do you have a way of snapshotting production systems in order to basically replicate the issue that's going on if it's something that's time-based or seems to happen again if you hit the button every hour to fix it, and then to see what's happening? I don't have a really good way right now. In the cloud, tend to use snapshots and just snapshot the state of the system and move on. Or what I often do is rotate one or two hosts out of production in order to find out what's going on, leave them running in a degraded state and only affect a small percentage of users or direct traffic away. But there aren't any great ideas. You can move those instances into a lab or into a staging environment. There's a few other tricks you can pull to dump the state of the system, but there really aren't great ones because a lot of times when you're working in production, it's only the production load that makes it show up as something terrible. And the moment you take the load off, the system starts performing great again. The talk last night by Brendan was actually really interesting because he talks about not debugging in production a lot of times with dtrace because it'll actually impact the load enough up to 200 times. And so you turn on your monitoring, and the moment you start observing, suddenly you change the state and the way the system operates. Yep.
So just taking that one a little bit further, the idea of if you've got a problem in production, at least not killing it and not having to replicate it, but keep it going, but taking kind of what existing state you can from it and migrating it someplace else. You know, hopefully maybe the problem will remain, maybe it won't, but in assumption the problem will remain, you can figure out at least it would be impacting everybody else on that system.
That's right, yeah. Basically, the comment was it's a good idea to keep rotating. I think that's, I'm going to summarize for everybody else, was keep your systems around, and then what we would do is we'd actually deploy a cluster or a bunch of hosts in parallel, and then we just throw the load balancers over towards that, direct the traffic at a system that was newly and fresh and able to take on the load, and then you can worry about the old ones later. The quick physical example, and I couldn't take any pictures of the cloud because the cloud's boring and ethereal and there's no good pictures of it. So if you take my printer example, is you rip that one out of service, you deal with it later, you take it apart when you have time, but you get back to running. And I hate the idea of saying reboot it every hour if you've got a production problem, but sometimes that's the way you keep it up. There are systems in place right now at big, scary organizations that you don't want it to be, where reboot it every day is a normal thing. I used to work at a place where we had a monthly reboot cycle where every single host must be rebooted every 30 days to make sure that they will come up no matter what. And it was basically an interruption of service test of the entire system to make sure that when you reboot it, it's going to come up in the same space you want.
My question wasn't quite that. It was migrating the
Can I get you on the mic? Sorry. I just realized we've got people on the live stream and you won't be able to hear anything.
So my question was more around if you've got the system, don't kind of reboot it, but keep it running, but move the state off of that to somebody else. Not so it's running, it's got a problem. You don't want to kill those sessions or whatever you've got running there. You want to move them someplace that's safe, and then you can try to diagnose. So I'm wondering about what you're thinking on tools and tool chains for that.
It depends on the architecture of your system. It depends on which load balancers you have available to you. It depends on what your actual system is working on. So if you've got long-running TCP WebSocket connections, that's different than if you've got UDP packets coming in that can be redirected at will. And so it really is system dependent. Maybe we can take this off for after, because I don't think I have a good answer in front of everybody. I think I need to think on that a little more. A few more questions?
Can we just get the mic there?
Not so much of a question, but you were talking about staging environments and stuff like that too. How many environments have you seen where staging environments don't resemble production at all, like not even a little bit?
My favorite saying is staging is a lie. Because usually we take staging and we try and handicap it in some way or make it we make it something so that it doesn't affect production, it doesn't touch our production databases, it doesn't see production load. And so it's a great big lie that we use to fool ourselves into seeing whether it's going to work. There's a lot of big houses that have done some great talks, guys at Etsy, guys at Twitter and Facebook, about throwing new load onto new services at 1, 2, 3% intervals and just seeing what happens in production. The idea of being able to clone production from the same scripts in just a different place and just not pointing a load balancer at it is probably where I'm leaning towards going in the builds I'm doing right now, just because we want to make sure that we give our developers a production environment that's exactly the same. The only difference will be the URL at the front end of it.
Last question and then...
Okay. Apparently we need coffee, so I'll give you the last question.
Can you describe or elaborate on the describe it step? We just are kind of at that stage now and had limited success with getting data from people and still doing a lot of reverse engineering of things. So,
the way that I've always started with it is just start with writing it down on paper or in a wiki or wherever you've got it, and get everybody to contribute the steps that they go through to do a build, and then sit there and watch them do it and make them actually run through those processes, and have somebody either sit over their shoulder or watch a session or steal the command history, steal the bash history if you have to of the system, if it's an Ubuntu box or Linux based. Do whatever you can to mimic everything they did. Just get them to do it. Don't worry about automating it. Don't make it elegant. Don't make it anything. Just make it happen. And then once you've seen what they're doing, then either you can teach them the tools that they need to be able to learn how to put that into production themselves, or you can go and take those steps and automate them yourself. I'm in a process right now where I'm taking a bunch of make files that the developers built of how to automate their own personal environments, and I'm turning that into production implementation. And so I'm taking make files and dependencies, and I'm doing a lot of make-n to see what's happening, and then I'm going through and step by step going through what's this depend on, why does this, do all these dependencies still exist anymore, and basically a sober second thought on it as I'm trying to push for production. There is no one right way. It's just get everybody talking and then watch them do it, because you'll find the secret steps where they're like, oh, we always put it on here because this is the data disk in this environment. And you go, well, that's not my data disk in my environment. Or they're throwing logs onto mount, and that's great, but when mount fills up, then you're dead. Sometimes you have SAN volumes attached and you want to throw everything on there. Sometimes you want to make sure you don't overflow your root volume so you can still log in when your logs overflow. And I think Phil's got an announcement with some coffee and maybe some snacks or something like that.
Yeah, very brief coffee. And then back here in 10:30, Tufik has a talk on analytics, something to do with analytics. Anomaly detection, that's what it is. So yeah, 10:30, back in here. Cheers. Thanks, Chris.